Introduction to Chemistry, Lesson 1.1, Matter. Chemistry is the study of matter. Matter is anything that has mass and takes up space. Let's look more closely at what is matter. Is this matter? The sun. Does the sun have mass? Does it take up space? Yes, so it's matter. Marbles. Marbles have mass and take up space, so they also are matter. Heat does not have mass and does not take up space, so it is not matter. Ice has mass and takes up space. And cold, which is the absence of heat, does not have mass and does not take up space, so it is not matter. Types of matter. We'll first talk about pure substances and then move on to mixtures. Every sample of a pure substance is identical to every other sample. For example, water. Every sample of water is identical to every other sample. The same is true with oxygen, and the same is true with gold. An element is a pure substance made of only one type of atom. Gold is only made of one type of atom, the gold atom. A compound, on the other hand, is a pure substance composed of two or more elements chemically combined. For example, water is a compound made up of hydrogen and oxygen atoms combined in a 2:1 ratio. I also consider oxygen gas a compound, though it's made of only one type of atom, oxygen atoms chemically combined. Because they are chemically combined, I consider oxygen gas to be more of a compound, though some people will call this as well an element. In summary, we've been talking about pure substances. A pure substance is a substance in which every sample is identical to every other sample. A pure substance can either be an element or a compound. An element is a pure substance composed of the same atoms, whereas a compound is composed of two or more elements chemically combined. A mixture is a type of matter composed of two or more substances physically combined, not chemically combined. For example, a bowl of raisin bran cereal consists of bran, raisins, and milk. It's a physical mixture. Air is also a mixture. It consists mostly of nitrogen gas and some oxygen gas and various other gases. A homogeneous or homogeneous mixture, which is also referred to as a solution, is the same throughout. It is uniform in appearance and composition. For example, a pitcher of Kool-Aid is the same throughout. And air is a homogeneous mixture. A heterogeneous mixture, on the other hand, is a mixture that is not the same throughout. For example, a bowl of raisin bran cereal. You've got your milk, your bran, your raisins. Clearly, it is not the same throughout. In summary, mixtures are two or more substances which are physically combined, not chemically combined. A homogeneous mixture is the same throughout, whereas a heterogeneous mixture is not the same throughout. Homogeneous mixtures are also referred to as solutions. Separation of mixtures. Since mixtures are physically combined, they can be separated by physical methods, which are methods based on physical properties. One such method is filtration. Filtration is the separation of a mixture based on particle size. The part of the mixture whose particles are larger than the pores of the filter paper are retained in the paper, while the part of the mixture whose particles are smaller than the pores of the filter paper flow through to the container below. Clearly, it is difficult to separate a mixture of two different liquids using filtration through a paper filter. A mixture of liquids can be separated using a process called distillation, as long as the liquids have different boiling points. The liquid mixture is heated, and the liquid with the lower boiling point evaporates first. Its vapor travels through a condenser, which cools the vapor back to a liquid by surrounding it with cold water. The resulting condensed liquid is collected in a flask on the other end. the higher boiling point liquid is retained in the original flask. Matter can be classified as either a pure substance or a mixture of substances. A pure substance can be either an element, which consists of only one type of atom, or a compound, which consists of more than one type of atom, chemically combined. A mixture of substances consists of more than one substance physically, not chemically combined. A homogeneous mixture is the same throughout, like a pitcher of Kool-Aid. Homogeneous mixtures are referred to as solutions. A heterogeneous mixture is not the same throughout, like a bag of trail mix. Matter has both chemical properties and physical properties. Chemical properties are characteristics which can be seen as one substance is chemically transformed into another. For example, a chemical's reactivity with another chemical, iron's tendency to rust, to become iron 3 oxide, and flammability, a substance's reaction with oxygen. These are all chemical properties which can only be seen as a substance is chemically transformed into another. Physical properties, on the other hand, are properties that can be observed without changing the identity of the substance. For example, smell, color, solubility, boiling point, and volatility. These are all physical properties that you can observe without changing the identity of the substance. Let's practice distinguishing between chemical and physical changes. The boiling point of water is 100 degrees Celsius. Is that a chemical change or a physical change? Since it doesn't describe water's reactivity with another substance, or is not observed as water becomes another substance, it is a physical change. Iron rusts in air. Iron forming iron 3 oxide is a chemical reaction. It describes iron's ability to react with another substance, so it is a chemical property. Acetic acid, 1.0 molar acetic acid, has a pH of 2.4. pH is a measure of the concentration of hydrogen ion in solution. The concentration of hydrogen ion in a solution describes a substance's ability to react with other substances, specifically bases. Therefore, as pH describes an acid's ability to donate hydrogen ions to another substance, it is a chemical property. Ice is less dense than water. This can be observed without changing ice into another substance, so it is a physical change. There are 3 common states of matter with which you are probably familiar: solids, liquids, and gases. A solid has a definite volume and definite shape. A liquid has a definite volume but does not have a definite shape. Liquids take the shape of their container. A gas does not have a definite volume nor a definite shape. Gases take the shape and volume of their container. Chemical versus physical changes. A chemical change is a change in the chemical composition of a substance. Atoms or molecules are rearranged. A physical change is a change in the physical state. The atoms or molecules are not rearranged. An example of a chemical change is the formation of rust. Iron reacts with oxygen to form iron 3 oxide. An example of a physical change is the freezing of water. Let's practice distinguishing between chemical and physical changes. Boiling water. Boiling water changes the state of water from liquid to a gas, so it is a physical change. Glass breaking also changes the physical nature of the glass, not the chemical nature. It doesn't become a new substance. Atoms are not rearranged. Burning paper. When paper is burned in the presence of oxygen, it becomes a new substance. Atoms are rearranged, so it is a chemical change. Iron rusting, we've already seen on the previous slide that iron rusting is a chemical change. This concludes Lesson 1.1 on matter. Please proceed to Quiz 1.1 before continuing on to the next lesson.